Well, good morning, good afternoon, good evening, depending on where you are. And as Lance said, welcome to talk 3 of 5. This is a topic that really is quite enormous. As I sat down to decide what we should talk about in this brief webinar, I decided that we should take a look at protection schemes, because that's usually one of the first things that folks think about when they are putting a network together is, how do I protect my traffic, right? How do I guarantee my my customers are going to have their services protected as they cross my enterprise? So as we have done in each of these talks, I'm going to start with this slide because I think it's a great way to kind of level set where we are in the protocol stack, and also associate cost effectiveness with that, which I think you really can't separate those. So in my in the upper left corner, you see my upside down triangle. Those of you that have been on talks 1 and 2, you've seen this before. But briefly, this is a cost triangle. The wider the triangle, the more cost is involved. So down at the bottom, we have optical, or some people refer to it as the DWDM layer. We talked about that last week. If you missed that talk, and if that's of interest to you, then certainly you can go back and check that out. Above that, we have layer 2 switching, right? So this is Ethernet switching done at the data link layer. This is just the second layer in the OSI model. Above that is layer 3, which we typically call routing. So this is OSPF, ISIS, BGP, and so forth. So each of these layers provides a different set of capabilities. There is some overlap in terms of functionality, but in the main, they are separated because they provide unique value in terms of network design. But as you can see, if you design a network to move packets from one location to another, and all you need is layer 1, then that's going to be your cheapest option, right? Doesn't mean you can't build a network out of layer 2 or layer 3 equipment and protocols, but it's just going to cost you more, right? So this is really a critical element, and really what we start with every time we are designing a customer network. It is, what is the lowest layer that we can push traffic to and still accomplish our objective? So as I mentioned last week, we talked about layer 1. This week, we're going to talk about layer 2 and layer 3, right? So when I mention IP, we're typically talking about layer 3, and Ethernet, we're typically talking about layer 2. For ribbon, that means if you look at the frisbees on the right-hand side of the screen, that's our Neptune device, which is capable of layer 2 and layer 3. It can sit on top of an optical network. As I mentioned last Tech Talk, we typically will build an optical network as a foundation, and then you can run your layer 2 and layer 3 traffic over it. However, that's not always necessary. In some situations, a purely standalone layer 2 or layer 3 network is perfectly valid, right? And so we're going to talk about that today, particularly in terms of resiliency. So again, layer 2, Ethernet. There are a number of strategies that you can use to provide resiliency. These are really kind of the 3 most common, I think. So lag is one of them, just link aggregation groups. I'm sure many of you are already familiar with those. Essentially, it's bundling multiple ports together. It not only gives you more bandwidth to deal with, but in the event of a port failure or a card failure, your service will stay up. So that's, I don't have that one listed here, but that one's really fairly straightforward. Multi-chassis lag is primarily used where you have a switch that needs to connect to two other devices, usually where you've got a couple of routers, right? So routers are almost invariably deployed in pairs. At some point, because we're not putting pairs everywhere in the network, that would be cost prohibitive. At some point, you have one box that has to connect to two boxes, and you need to do that in a resilient fashion. Multi-chassis lag is a way to do that, and connect to both of those in the event that a link or a card or an optic goes down. G.8032, been around for a long time, also known as ERPS, Ethernet ring protection. There's a V1 and then there's a more recent V2 version, but they're both pretty old. I won't call them obsolete because they are still used quite frequently in access rings. I know the larger access device manufacturers are still putting ERPs out there, and it's fairly simple technology, and it works. And so I suppose the theory is, why change it? However, it has largely been superseded, particularly on the backbone, by MPLSTP, which is easier to configure, and I won't say it's more reliable, but certainly fairly straightforward in terms of how it's deployed. And so we will talk about MPLSTP. It has those four letters in it, MPLSTP, right? This is not MPLS. For those of you that aren't familiar with MPLSTP, this is it's not exactly a subset, but it's designed along the same lines. It is MPLS transport profile, and as you'll see in upcoming slides, it's very straightforward in terms of how it works. Very reliable, and easy to deploy. On the layer 3 side, on the routing side, of course, you have routing protocols, right? And I'm including MPLS here. MPLS kind of, I think traditionally we put it at layer 2.5, but let's just call it what it is, right? It's a routing protocol. So these are protocols that are very mature, have a lot of metrics, a lot of ways to define your network. And the reason why they are much more complex than, say, the layer 2 alternatives is because they are deployed frequently in a partial or a full mesh topology. So you've got many nodes connected to many nodes, and a packet that is moving from one side of that network to the other may take one path to go left or right, and then another path to come back the other way, particularly if there are failures within the network. So it's very resilient. This is how the internet works, right? So it's extremely resilient, but it can be very complex to administer the larger the network gets. It also depends upon what's called convergence. So a convergence, or the convergence of a routed network, is when all of the routers agree on what the map of the territory looks like, okay? When there is a fault or a change somewhere in the network, then that triggers a convergence. And so the routers, based on the protocol, they all communicate with each other. They look at the metrics, they say, how much does it cost in terms of time and hops to get from this location to that location? And they all talk to each other and they all come to an agreement. And that period of time is called the convergence time, right? The more complex the network, the longer it will take to converge, and the more CPU and memory it takes. This is why layer 3 is much more expensive, because it is fairly CPU and memory intensive. It's very resilient, as I said, but there are some drawbacks. Then we've got EVPN, which is a fairly newer technology. It is deployable in a number of topologies. There are multiple modes that EVPN supports. Primarily, one of the modes allows active-active connectivity. And so we're going to take a look particularly at EVPN and then how it was deployed in a particular, in one of our customers. You may find that compelling for your situation. So starting with layer 2 switching, we're going to talk about MPLSTP. So here's my sample network. I've got 6 nodes there from A to F. So in this particular scenario, I have traffic flows that are going from site A to site D, okay? And so MPLS basically sets up 2 tunnels, a tunnel from A to D through nodes F and E, and then a tunnel from A to D through nodes B and C. And so one of those will be designated working and one will be designated the protect tunnel. Every service that I put in that tunnel will be protected because it's done on a tunnel by tunnel basis, right? So I could put 1 service in it, 4 services, 6 services, whatever, right? And they'll all be protected in exactly the same way. So what's unique about MPLSTP is that you are establishing working and protect tunnels and in effect routes from the get-go, right? When you set up a service between A and D, you can build an MPLSTP tunnel that goes through F and E on one side and through B and C on the other side. And then those tunnels are established. They're nailed up. You never have to touch them again. Later, if you're adding another service from A to D and there are already tunnels built, then your task is even easier, right? You just put it into the existing tunnels and they come out on the other end, okay? There's no add drop in the middle, right? If you need to stop at site F or E, then you build another tunnel from A to E through F, right? That would be the way that goes. It works just like automobile tunnels. There's no stops in the middle, right? There's no exits in the middle of a tunnel. You go into a tunnel, you come out the other end. Okay. So when you set up working and protect, and this, you get to decide which one's working and protect, all of your traffic that enters that tunnel is going to go through the working tunnel, but it knows it can use the protect if it needs to because that protect tunnel is already nailed up and configured. When a fault is declared, which typically happens within 10 milliseconds, all traffic, all services within that tunnel immediately switch to protect, and now protect becomes working. So very, very straightforward, right? You nail up tunnels at the beginning, you put your traffic in them, you get to decide whether, what the routes are. In this case, it's fairly simple ring topology, but if you have a more complex topology, then obviously you can choose the route for both working and protect. Reverting back to the original working path can be automatic. You can put a hold timer on it, and then the system will continue to test the old working but faulty path. And if it comes back up again and meets your requirements, then you can have the service revert back automatically to working. And this happens again sub 50 milliseconds. Or if it fails, you can decide, no, I want a human being to look at it. So keep it on the protect path, and then I'll go in and make sure that the working path, the old working path, is actually working. So as I mentioned a couple of times, it's very easy to use, very reliable, sub 50 millisecond failover, based on the old SONET standard. The cons, if you will, is that it's really kind of limited in terms of architecture, right? This is not, if you want a working and then 2 or 3 protect paths, then MPLSTP is not the way to go. If you have a point to multi-point, if you've got a full mesh or a partial mesh situation, then again, MPLSTP is not the way to go, right? So it's a very valuable tool where you have a ring topology, very common in rural architectures, as I'm sure you're aware. And you have services that are running around that ring. Honestly, it's fairly common to see a ring topology like this where sites B, C, D, E, and F are all directly logically connected back to A, and A is your hub, right? So that works as well, right? So if I have A to D, I can also have A to C, A to B, A to F, and so forth, right? So, so that's MPLSTP. So the competing technology, if you will, it's really not much competition anymore, but this is one that you'll see out there, particularly if you have access rings. 8032 is a ring protection. It is designed specifically for rings, so it's somewhat limited in terms of the architectures where you can put it in place, but it works a little differently. So in a ring, it's the same ring that I had before, but in an 8032 situation, every site talks to its neighbors and establishes a communication about the health of the link that they're directly attached to. So in other words, A and B talk to each other and say, I can still see you. Yep, I can still see you. Therefore, span AB is good, right? B and C talk that way, C and D, and so forth. So once all of that is established, then in the ring, the nodes will determine a ring protection link. In this case, I've designated it span AF. So between A and F, that span is actually up and good. However, to prevent ring ring issues, loops, and so forth with your traffic, that route, that span between A and F is placed administratively down. So that effectively turns this into a linear network that goes A, B, C, D, E, and F. And then traffic from F to A goes F, E, D, C, B, A. Okay? So all nodes, again, are communicating with their neighbors consistently. When a fault is declared, again, usually about 10 milliseconds it takes to declare a fault, then and let's say that fault is between B and C. Then B and C say, hey, I can't see my neighbor anymore, and they declare a fault. That tells A and F that they can open up the ring protection link, and now that link carries traffic. So if my fault is now between B and C, then traffic between B and C will go B, A, F, E, D, C, and then it will reverse and go the other way, of course, because all traffic is bidirectional. So that's how 8032 works. Again, it provides sub 50 millisecond failover. It is fairly easy to use. It is a different type of failover, but just as valid. It's not quite as easy to deploy as MPLSTP, and it doesn't use the tunneling technique. So you've got to turn one of these up for every service unless you combine it with another type of protocol. Again, reversion can be automatic or manual in terms of where the RPL is and the administratively downlink. So this is probably going to be around for quite a while. Again, I've mentioned before that the access vendors out there, the PON vendors and so forth, seem to really like ERPs, and so I think it's probably going to be around for a while out there. Okay, so we're going to move on to sort of layer 2, layer 3. This is really more of a layer 3 technology. EVPN is a more recent protocol that provides really a lot of value. This is a very big topic. Feel free to ask your questions in the chat as this comes about. There are 4 modes of EVPN. We're going to take a look at just one of them today. And even in that, we're limited by time in how much we can go through it. I want to mention right off the bat, though, that this is very easy to deploy, right? I think it's 4 lines of code in the CLI, very straightforward. and the power and value that it brings to your network is really pretty unprecedented. So as I mentioned before, EVPN can be configured for active-active. What that means specifically is, instead of having a working and protect, you've got two working links. So you've got double the bandwidth effectively. You're not stranding any bandwidth across a pair of fiber. You can also use it to multi-home. So much like multi-chassis lag, where I need to connect one device to two devices for resiliency, I can use EVPN to do that. And that's what you'll see here in our example in the next slide. You can deploy integrated routing and bridging, so you can route between subnets. It allows MAC mobility. So if you've got mobile users that are moving from one Ethernet segment to another, then this can accommodate that quite easily. Very, very fast convergence. Even though it's layer 3, you're deploying it in a fairly limited sense, with a handful of devices rather than hundreds or at least dozens. So and the IGP fast reroute and BGP PIC are two technologies that can really do speed things up in terms of convergence. Again, convergence, for those of you not familiar, means that all the routers have a common map of the territory and know exactly how to forward their traffic, right? Absolutely essential for traffic forwarding routing. It is interoperable with, say, MPLSTP networks. So it works really well at the edge of an MPLSTP network, where you have to interface, say, with an MPLS cloud or a routed environment. It also allows per flow load balancing. So it gives you granularity in terms of the traffic flows that are going across your network, and allows you to load balance them across multiple links. Okay, so lots of promise here, right? I'm not getting too far into the configuration. Actually, really not getting into the configuration at all. But this is the value. So if these sound good to you, right? If this is a situation that you're kind of struggling with how to configure, then EVPN may be an option for you. So here's a quick customer example of this. So the requirements were, in looking at the diagram, we've got access equipment in the orange, right? So this is, just to use a couple of names, your Calix, your Adtran, your PON equipment out there, fiber to the prim. They have, in this particular case, this customer had fiber, dual path fiber that connected to 2 or more of the distribution backbone nodes, right? So in this particular case, the yellow nodes would be where the ribbon switches were, in this case, routers. And so because we had redundant fiber and connections to redundant nodes, we wanted to look at a strategy where we could provide that resilient connection to the backbone in the event of a failure, and then active-active traffic flows. So I can use both connections and I can load balance across them, right? So lots of value there, as opposed to saying an older technology like multi-chassis lag, or, God forbid, spanning tree. Like I said before, it is fairly easy to configure because of the rapid convergence that's built in. You're going to get very rapid failover from one location to another. In fact, you can't even really call it failover because it's active and active. So your traffic is going to be flowing and will flow consistently. If you lose one of those links, traffic will just flow entirely through the remaining link, right? So full usage of your links, extra resiliency. In this case, we have 2 different sub rings here. We've got the ones connected to the 2 routers via the purple links, and then the one with the blue-green links. And this is continued all the way around the network. So they have basically built themselves a very, very resilient access to distribution interface, which is really where EVPN shines. Okay, so brief overview there of some of the technologies that are out there to protect your traffic. This is a slide that basically walks you through the design and planning process. So for rural networks, we very frequently see a ring upon ring type topology. Occasionally it's hub and spoke in terms of physical fiber, but very frequently we've got rings out there. So we take that topology map, and then most importantly, we look at the traffic routes, right? So going back to this, the fiber shows you one element of this network, but how you want that traffic to flow. And, do you want active? Is active and standby adequate for you? What does your fiber look like? But then most importantly, what are the traffic patterns that you need to implement across your physical fiber? Then what are your site types? What protection methods are most important to you? I think everybody's just pretty much agreed upon sub 50 millisecond failover, but how many hops do we have between the beginning node and the terminating node of a service? What are the routes? What kind of technologies? Is there an optical layer underneath? Are we deploying primarily Ethernet layer 2 technologies? Do we need full MPLS? Are we interfacing with an MPLS cloud and running a layer 2 network? These are all questions that you need to ask, and then think about your answers to. And certainly our engineers can help with that. It's part of designing a network for our customers. Once all of that data collection takes place, that's when we start assigning network elements, and then we can build and simulate that network virtually in our design tools. And then of course, bring it back, do some whiteboarding, and decide, you can decide whether this is the way you want to go and if any changes need to be made. So each of these technologies, of course, as I've walked through them, each one of them has pros and cons. There's not one that works best for everyone. You might say, well, layer 3 is great. It's the most resilient. I can do any topology. That's great. Remember my upside down triangle. It's the most expensive, right? So all of this is a balance. We throw it all into the hopper and then prioritize and come up with a design that not only meets your requirements, but then of course is cost effective. So just briefly, these are the shelves that we use. There are others out there, of course, but these are the shelves that we use to deploy these technologies. Our switching and routing platform is called Neptune. What is available today is the Neptune 1000 series right here. Coming shortly is the 2000 series, which is an additive product line. The 1000 series is not going away. These are deployed by the thousands, actually tens of thousands worldwide. So they're certainly not going away. The 2000 series is simply a bump up in terms of interface types, adding the new 400 gig Ethernet optics and interfaces, much bigger switch fabrics, much bigger fibs and ribs in terms of the routing tables. So you'll have the choice between the 1000 series and the 2000 series in terms of what's most applicable for your network. The value proposition, one additional value proposition of Neptune, I've been walking through layer 2 technologies and layer 3 technologies. So what if I decide to go layer 2 initially, but then at some point I decide I need to go full MPLS and I need layer 3? Well, with a lot of vendors, what you have to do is forklift that switch and put a router in. Not the case with Neptune. Every Neptune comes off the line capable of both layer 2 and layer 3. If you need layer 2 and you don't need layer 3, then you don't pay for layer 3. The way that it's implemented is with a simple key code that turns all the layer 3 features on. So this allows you to deploy layer 2 initially. As you grow, you may find that a full IP MPLS network is important, or in certain parts of the network, say you may want to deploy EVPN. So MPLSTP on the bulk of your network and EVPN at the interface with, say, an MPLS cloud. So in that case, you would only need to turn on layer 3 capability on a few nodes, not on every node. And so you only pay for those, right? Again, this is a design philosophy that Ribbon implements to allow you to put whatever device in that you need at the time. If you never need layer 3, then there's no reason for you to pay for it. But no forklifting. Okay. This is the sort of table stakes protocol set. A lot of these we've talked about here, but there are certainly many more here that we couldn't cover in half an hour, 45 minutes. You are all going to get a copy of these slides. So these are basically what we consider the basic protocols that need to be supported by your layer 2, layer 3 platforms today. This is not an all-inclusive list. There are pages and pages of standards that are adhered to and additional protocols and so forth. But these are the ones that are most important. Okay, so I've kind of hit you with a fire hose here, and because of the time constraints, I've limited it specifically to protection and resiliency. We talked a little bit about architecture. This tech talk is designed to go within the set of 5 tech talks. Next tech talk, we are going to go through DWDM, switching and routing. Why would I use one over another? We kind of touched a little bit on that today, but we're going to start to bring it together between the optical layer, the Ethernet layer, the routing layer, and give you some pointers on how all of this goes together. Do I need one over another, and why would I choose one over another? So here at Ribbon, we call this entire product portfolio and this topic, we call it IP Wave, to illustrate that it's both IP and DWDM and everything in between. So think of it as a toolbox with lots of different ways to accomplish your goals. Your end customers don't really care what protocols you're using, and quite frankly, neither should you. As long as they meet your objectives, they perform admirably, and you continue to make money. So we take a very holistic approach in terms of how to design a network. We are not rule bound by well, it's got to be MPLS, or it's got to be 8032, it's got to be one thing or another. We support them all, and so whatever's best for you is what we consider best. Everything we do is standards based on both IP and optical sides. From a deployment standpoint, very mature technology. Our company on the IP optical side has been around for decades, even prior to companies like Nortel. So very, very mature and very widely deployed globally. We don't charge any persistent licensing fees. So when you are purchasing software from us, once you've bought it, you own it, right? So if it's Ribbon software, we don't send you a yearly invoice to relicense all of our software. You buy it, you own it. We have deployed a pay-as-you-grow model. This is, a good example of that is a Neptune device, which is capable of full layer 2 and layer 3. But if you don't need layer 3, don't pay for it, right? If you want it later, it's a simple key code, right? So one of our design philosophies is to design for you today, give you scalability for tomorrow, and an easy transition without forklifts as you grow. We are Buy America Act compliant. For those of you in the rural spaces and Utelcos, you know that the government and the public sector has put a tremendous amount of investment into broadband stimulus, bridging the digital divide. Often, if you are taking government money, then you must adhere to the Buy America Act. Ribbon's equipment is Buy America Act compliant, and we can provide that legal paperwork to make sure that you're kept whole there. And then currently, we are running 10 to 12 weeks delivery on all products. I had a conversation this past week. Actually, was giving a presentation down in Georgia, and really every person who got up there talked about supply chain. Every time you get together, supply chain is really near the top of the list. Through a combination of good planning and shortening our supply chain before COVID even hit, we are still able to deliver everything in our portfolio between 10 and 12 weeks. So if you are coming up on a deadline and you need to get something deployed, give us a call. We can certainly talk about that, and hopefully we can help you. And then finally, I want to extend an invitation to the Ribbon Tech Forum. I'm sure if you've been to any of my other tech talks, you've seen this slide. If this is your first tech talk, welcome. We have a much more in-depth tech talk, if you will, multiple tech talks. We're going to be delivering in person down in Dallas the first week of November. It's going to be at the Westin Galleria, which is a very nice, very large venue in North Dallas, very close to DFW Airport. So easy in, easy out. Registration is now open. The URL is there on the lower left. And of course, you're going to get a copy of this presentation. So if you don't want to write it down right now, then you'll get it here later. But that's where you can sign up. It is going to be limited attendance, right? We want to make sure we deliver a quality experience for everybody who comes. And so it's basically first come, first serve. So there are seats still available. So if this is of interest to you, certainly get in there and register. We will be doing product demos of our established technology and then even some new stuff, right? That I think you're going to find very interesting. We're going to have a variety of experts to talk on any number of subjects. It is largely rural and Utelco focused. So if you're a rural telecom provider or a Utelco or a Muni, you are not going to be elbowed aside by AT&T and Verizon folks, right? We initiated this primarily for you, and so I think you're going to find it of great value. And then as well, if you want to bend the ear of one of our executives, they're all going to be there. And if you would like some one-on-one time with them, then we can certainly schedule that. So Ribbon Tech Forum, November 2nd and 3rd. November 1st will be a golf outing, because why would you do this without playing golf? So that will be something you can sign up for as well. All right. So enough from me. Thank you very much for your time. This has been the third of 5 sessions. Next time, we're going to be talking about multiple layers, DWDM layer, Ethernet layer, routing layer, where, when, and why. And so we'll kind of put the building blocks together and talk about network design and why would I use one technology in a particular place over another. And we'll put some live examples or real life examples out there of how other people decided to go about it. Hopefully give you some ideas. Again, thank you so much for your time. And Lance, I'll turn it back over to you.
Thank you, Jack. And thanks everyone for attending today, and thank you for your questions. Before we get to a couple questions that we had, I did want to point out, Elizabeth did put in the chat the same link you're seeing on your screen, so it may be easier just to check that chat area. Click that link, you can check out the website for the Ribbon Tech Forum. In addition, she mentioned we are planning another series of Tech Talks, so chat in your ideas, your topics that you want to hear. We'd love to build these specifically for you. That's why we're here, right? So whatever topics you feel like you want to hear from us and want us to cover, put those in the chat and we'll take note of those. We did have a couple questions. I'll just kind of run through them in order here. Chris sent this one in. How does MPLS IP work differently than MPLS TP? So I know, Drew, you answered that via the chat, but maybe you can answer it verbally for anybody who might have missed it.
Sure. MPLS-TP is more of a subset of MPLS. So rather than having to build a full IGP and build your label distribution and your label switch paths based on an IGP, you're essentially instructing the system that this is my label switch path. I'm going from this node to this node to this node to this node. And so it's just a static label switch path rather than dynamic. In addition, since you build an active and a standby at the time of service creation, you've got that sub 50 millisecond failover time. Rather than having to wait for an IGP to reconverge, it just simply looks, when it sees that the active path is down, it flips to the backup path.
All right, very good. And kind of following up with that, I think a follow-up question was, what is the advantage of TP over IP? And yeah,
one of those is that fast failover, and the other is that, you know, with MPLS TP, you don't have to license the router for full, or the Neptune for full router functionality. We actually sell the MPLS TP functionality as a separate license item that comes in at a lower cost than the full layer 3 routing functionality.
Yeah, the other thing I'll mention is that they're not really competing technologies. It's not like you would use one over another. Again, as you move up the stack, you get more capability. So can I build a resilient network of a very simple ring with a full routing protocol? Well, sure I can. Do I need to is the question you should ask, right? Do I need to pay for layer 3? Or can I get what I want, which is sub 50 millisecond failover, working in protect paths on a simple ring topology using a layer 2 like protocol like MPLS-TP, right? So, you know, a good example is MPLS-TP works really well on rings, right? Because you can go left or you can go right, okay? And that's my working and protect. Where I have a full mesh, where I have, say, 2 dozen
partial
nodes,
mesh,
yeah, and they're all connected to each other, and I have almost infinite paths to get from one side of the network to the other. MPLS-TP, you could build 2 paths through that, but if both of those links fail, then you're dead in the water. Whereas full IP MPLS can give you infinite paths to get across, and if one fails, it goes to the next path. If another fails, it goes to the next path. If another fails, it goes to the next path. So you get more for your money. But the key here, and I kind of addressed this in the design, on the design slide, but the key here is, what do you need for your topology, right? And how do we accomplish your goals in the most cost-effective manner while maintaining, you know, your quality of service? Good question.
Thanks for that. Yeah, good question.
Good question.
Thank you for that. Thank you for that, Chris. Appreciate that. And we've got one more. So while we're talking through this, if you have one on your mind, please type that in. But does the Neptune offer any first hop redundancy protocols like Cisco's HSRP or FHRP?
The answer is yes. We do virtual router redundancy protocol, or VRRP. So if you're using that IRB function and having the Neptune act as the next hop, if you've got a pair of them, you can then use VRRP to maintain a single next hop address. kind of a layer 3 resiliency protocol that doesn't quite go as far as like OSPF or ISIS.
Very good. Okay. All right. Well, that's all the questions we had today. Again, I want to encourage everybody to be on the lookout for the email coming your way this afternoon with a link to the replay of today's webinar. And when you see that link, there'll likely be other links to the previous replays. You can check those out if you missed those as well. And the slides too. We'll have the slides attached to that so you can check it out. Again, the next webinar, if I am not mistaken, is coming up September 13th, I believe. And I think you mentioned that topic, DWDM, switching, routing, how do I choose, right? So that's on its way, so we hope you can attend that one. Again, Ribbon Tech Forum on your screen, take a look at that, and drop us a note. If we send you the email today, you can reply with your questions, you can reply with other topics you'd like to see. Feel free to communicate. Well, we get those directly, and we'll pass those on to the team that's on the call today. Thanks again for your attendance today. Thanks, Jack. Thanks, Drew. Thanks, Elizabeth. We will talk to you all soon, and have a great rest of your week.